Let's imagine this for a moment. You are sitting still in a room, your phone is in your hand, and your body is barely moving. But when you hear this, it starts to feel a little strange. In fact, you are moving through the universe at an incredible speed right now. Really, it only feels like you are staying still. First, Earth is rotating. Earth spins once on its axis every day. That is why we have day and night, and Earth orbits the sun. It makes one full lap in a year. Up to here, this is familiar, but it does not end there. The sun is not a fixed center point either. The sun, Earth, and the entire solar system are moving through the Milky Way. According to NASA, it takes the solar system about 230 million years to orbit the center of the Milky Way. 230 million years. During the year we experience, Earth goes once around the sun, but the solar system has only moved a tiny bit through the Milky Way. The speed is absurd too. The solar system is described as orbiting the center of the Milky Way at about 829,000 kilometers per hour. The number is so huge that it is hard to feel. You can just think of it this way. We live ordinary day after ordinary day, but in reality we are riding a giant cosmic bus called the Sun, racing through the Milky Way. Around here, a question comes up. If the Sun is moving too, what about the Milky Way? Is the Milky Way also going somewhere? The Milky Way is not alone either. Around the Milky Way are the Andromeda Galaxy and many smaller galaxies. These neighboring galaxies are grouped together and called the local group. The name sounds difficult, but just think of it as our galactic neighborhood. And this neighborhood also sits inside a larger cosmic map. One part of that is the huge supercluster called Laniakea. Even the name sounds like a fantasy game region. Inside Laniakea, galaxies are described as flowing almost like water in a river. And when people talk about that flow, the name Great Attractor also comes up. Just hearing the name makes it sound like the final boss of the universe. It feels like some mysterious monster pulling every galaxy toward it. But we need to be careful here. The Great Attractor is not the center of the whole universe. It is simply an important region used to explain the enormous flow of galaxies around us. Even so, it is fascinating enough. We thought we were just on Earth, but in reality, we are floating on a vast river of galaxies. Then the truly interesting question appears. If Earth orbits the Sun, the solar system orbits the center of the Milky Way moves within a larger group of galaxies, and that group is inside an even larger structure, shouldn't there be some kind of center at the very end? It feels like Russian nesting dolls, a small center, a bigger center, then an even bigger center, until finally the true center of the entire universe appears. That idea is completely natural. But this is where the universe betrays our intuition. Cosmic expansion is not like a firework exploding from one point and sending fragments flying outward. It is a little easier to think of raisin bread instead. Raisins are embedded inside bread dough. When the dough rises, the raisins move away from one another. No matter which raisin you sit on, the other raisins seem to be moving away. But can we say one of those raisins is the center of the bread? That is difficult. Here, think of the raisins as galaxies and the dough as the space between galaxies. It is not simply that galaxies are flying through empty space. It is described as the space between galaxies itself getting larger. There is also the balloon analogy. If you draw dots on the surface of a balloon and inflate it, the dots move away from one another. If a tiny ant lived on the balloon surface, it would see every dot around it moving away. But on the surface of the balloon, there is no center. Of course, the balloon has a center inside it, but that is an outside dimension used for the analogy. Calling that the actual center of the universe would be misleading. The key point is this: cosmic expansion may not have a center point in the everyday way we imagine one. Here is another confusing part. If the universe is expanding, is your body expanding too? Is the distance between Earth and the Sun constantly stretching apart? You should not think of it that way. Structures tightly bound by gravity, such as the solar system or a galaxy, are not described as stretching along with cosmic expansion. Cosmic expansion becomes important on extremely large scales, such as the enormous distances between galaxies. So, Earth's orbit around the Sun and the expansion of the entire universe both sound like motion, but they are really different kinds of stories. But there is another strange number. We can talk about our motion relative to the CMB, or cosmic microwave background. The cosmic microwave background is light from the very early universe. It is spread almost evenly across the entire sky. But there is a pattern where one side looks very slightly hotter and the opposite side looks very slightly cooler. Using that difference, we can say which direction we are moving relative to that background. NASA explains that the local group is moving relative to this frame at about 600 kilometers per second. 600 kilometers per second. At this point, you almost have to laugh. I was clearly sitting in a room, but when the reference frame changes, I am crossing the universe at an enormous speed. But even this does not mean absolute speed. If you are sitting on a train, you are still relative to the person next to you. But relative to the platform outside, you are moving. It is the same inside an airplane. Speed always needs a reference frame. The CMB is a very useful cosmic reference, but we should not call it the universe's absolute state of rest. This is the fun part. We are definitely moving. But the answer to where we are going changes depending on what reference frame we use. So the conclusion is a little strange but beautiful. We are spinning together with Earth. We are running through the Milky Way together with the Sun. We are moving with the Milky Way inside a larger flow of galaxies, and on the largest scales, space itself is expanding. But tracing all of this backward may not lead to a central station for the whole universe. We are not travelers heading towards some final center. We live in a universe where completely different motions appear whenever the reference frame changes. The first question was simple. If Earth rotates, the Sun moves, and galaxies move too, then where is the center in the end? But the answer is even more interesting. On small scales, we can talk about centers. For Earth, the Sun matters. For the solar system, the center of the Milky Way matters. But when we go to the universe as a whole, the word center may not work the way we know it. So the final question remains like this. Where are we going right now? Maybe the answer is not a place, but the reference frame you are using to look.